Mr. Zakir Ahmed, Senior Firmware Engineer, HP. He has a total experience of 13 years. He is presently associated with HP R&D Center, Bangalore, as a part of M&E from Samsung Research Institute. He has an insightful experience in Linux kernel development, device drivers, and embedded systems, multi-core environment, Android kernel, bootloader, rootfs. He has hands-on in developing power-safe functionalities, USB 3.0 full stack, USB device drivers, NFC SNEP solution to printers, SATA drivers development, hibernation, RAM dump, etc. He has worked on ARM, PPC, MIPS platforms with a variety of Samsung custom SoCs, OMAP board. He has merit of developing full features on printers which are commercialized in US and Korea B2B market. Now, I leave the session to Mr. Zakir Ahmed, sir. Sir,
Hello.
Zakir, sir.
Yeah, am I audible? Hello. Am I audible?
Sir,
Yes, sir.
you're
Audible,
audible,
sir.
sir.
Okay, great.
Audible.
I'm sharing my screen. Let me know if the screen is visible. Is my screen visible?
Yes, sir.
Okay. All praises to the Almighty, the Lord of the worlds, the most merciful, the most beneficent. We seek guidance in Him to lead us to the straight path. We pray to Him to give us good health and guidance, peace and prosperity throughout. We thank Him for providing us an opportunity to come together on the occasion on the FDP program and ATAL on the Embedded Systems Workshop. I, Zakir Ahmed, a senior firmware engineer from HP, would extend a warm welcome to one and all to the session on embedded systems, the present trends, technical trends illustrated via applications. Good morning to all of you. Good morning. Am I audible? Because the problem is since we are in the virtual world, I don't know when we'll be disconnected. So at least
Yes, sir.
somebody
Audible,
can
sir.
respond. Okay, great, fine.
Audible.
Well, so let's get started. How long is my session plan? Can somebody tell me, Miss Husna, how long is my session plan? Hello? Hello, Miss Husna?
Yes, sir, you can continue, sir.
Okay. So how long is my session plan? Till what time? 1 hour?
It's till 12:45, sir.
Okay, great, fine. Yeah, so before we start, so let's know the objective of the session. So the objective of this session is threefold. The resistors and the capacitors, the ADC and the DAC, the IR and the RFID sensors, the microcontrollers and the microprocessors, the flip-flops, etc. that you are teaching today to the students are just not at the teaching level, but they are used in the medical devices, which are used to save a life of a patient, are used in defense applications to defend the country against the enemies, are used in automotive electronics, starting from the infotainment to the sensing of rains to the alerting of a pedestrian to the inflating of the airbags during emergencies, in the field of telecoms to connect different devices, different people, different geographies over satellite communications, are used in the world of consumer electronics, making the lives of the people easier, convenient, affordable, and comfortable. That means to say, your stake is just not teaching the students, but your products that the students are creating from the studies that you have taught to them are used in all these things, which is just to say that you are part of the transformation touching millions of lives every day. Salute to all of your efforts, first of all. And this has to be percolated to the students right down there, saying that once you are graduated, the intention is clear that they are going to serve the humanity by bringing up gadgets, making the world easier, comfortable, and to have critical devices which are even touching the lives of patients. So that is the first objective. And the second objective is that it's an eye opener. So it's just not the simple RFID and IR sensors that you're teaching to the students, but simple things are making big differences. Small things make big difference. That means to say, you think it's just an RFID sensor, it could save a life of a pedestrian crossing the road and can be used as a feature in the automotive electronics. So it's an eye opener. So what teachings we are doing today, how it is extrapolated, used in the industry. And number three, based on this one, you can train the student projects which are industry relevant. So is the objective clear? I think we have to make the session a bit interactive because unfortunately we are in the virtual mode, and it's very difficult to get the pulse whether
Yes,
people
sir.
are
It's clear.
okay, fine. So, unfortunately, had it been a virtual ground, had it been a physical ground, it would have been a totally different ball game. So we could have had the head nods at least to see people are understanding or not. Being on the virtual, this is a bit challenging thing. Unfortunately, that your college is supporting only Google Meet. Had it been a Zoom kind of thing, we could have had some annotations also. But anyway, so let's proceed with it. So with this objective in mind, let's see what we have in store for today. So the agenda for today is we would be touching on the embedded systems, the propellers. Okay, just to mention a few things before we move here. So the topic that we are going to cover is only the embedded systems, technical trends with the illustration of the applications. We are not going to touch on the OS because that itself is a big topic. And 1 hour, I cannot do justice for two topics. And when I see the agenda, there is one more item which is already present for Dr. Mahantesh. He is taking the current trends in the OS. So I will not be touching on that. So moving forward, so what we have in store for today, embedded systems, what are the propellers? Why embedded systems have gone up suddenly? Not suddenly, but over a period of time. What are the propellers? What is fueling the growth of embedded systems? And what are the strengths and opportunities that we have being in the field of embedded systems that we can leverage and we can give back to the industry and the community? We would be touching four major domains. Five we thought of, but in the interest of time, we would be touching on just four major domains in the application space. In a sense, each domain we will try to see what are the current latest trend of applications that are coming up and future forecast of applications a bit, which is implicit out of that. The disclaimer is that this presentation is aimed at collecting all the data from different domains to give an overview in a single slide set. So I acknowledge, I thank all the material providers from the internet and to all the people whose material is being leveraged and evangelized in this presentation. What are the factors that are propelling the use of embedded systems? Number one, the ubiquitous computing. Any data, anywhere, anytime. The concept started off with pervasive computing with Apple Watch, Fitbit, etc. quite some time in the early 2000s. And that got extrapolated with many things becoming intelligent. A simple example for ubiquitous computing, you have a elderly person in your home and you are out and a person wants to come to your home as a visitor. So he rings the doorbell. So using ubiquitous computing, the message, the data is taken from the doorbell via the video and it's sent to the elderly person on his gadget, whether he can approve or reject his entrance. The same thing is sent to you on your mobile phone via an app, to somebody else via his email notification that either he can approve or disapprove the visitor. And over a period of time, this has given rise to intelligent devices, starting from your smart shirt, smart trousers, smart socks, smart shoes, smart belts, smart rings, smart school bags, smart baby bags, smart watches, smart glasses, smart rings, smart bracelets. Everything except human has become smart. So this because this, so the devices have become intelligent. They are either transmitting devices or receiving devices or behaving as a network, together forming a network of IoT, Internet of Things. So the DNA, which stands either device node or be a network or be an application. So this ecosystem is formed, creating or propelling or pushing the greater use of embedded systems across. Beyond this, the physical systems are getting a cyber tag to the systems. The physical, biological, and engineered systems whose operations are integrated, monitored, and controlled by a computational core. So this has become a norm now. For simple example, if you see, days before, a simple car used to have its own braking mechanism, accelerator. If you see the old Marutis that we had during our times, so it used to be a simple car. And over a period of time, that became the MPFI, microprocessor fuel injection. And over a period of time, now everything is getting cyber connected, throttle by wire, X by wire, brake by wire, ABS systems, anti-brake skid systems, all these things. So everywhere you are getting the cyber component connected. That means to say you need a device to have a relay to control the physical system, controlling the computation via the communication. So this is used right from the aircraft, air traffic control, automobiles, defense, health, electronic gadgets, and whatnot. So further to this, what has added is the context-aware devices. That means to say you are sitting here in India and you want to book a hotel in US. You might have observed days before during our college days and those days, had you wanted to book a hotel outside India or outside any place, so it used to show in dollars or something like that, right? So but now if you see, it's showing you in rupees. What is this? So it is aware that you're sitting in India and for you rupees matters, right? So same thing, if you go ahead, if you just extrapolate these examples, if you are booking a vacation with a family, your choices are different. If you are booking a vacation with your friends, your choices are different for adventures. So basically, the devices are getting the context where you are, how you are. All this information is getting added to the recommendation engines through AI, and this is fueling and propelling the use of embedded systems further. And one field which is not yet commercialized, but in the field of research, and also, in fact, things have improved over a period of in the past 3 years, is organic computing. See, all these things, we are just creating the thirst, and the whole idea of this presentation is to give a what information. We will not cover the how part of this one. So the how part, if you go in detail, everyone is a presentation by itself. So here we will be just covering the what part. So we will be moving a bit far in the fast pace. So anything which interests to you, you can take a note of it, and maybe you can either reach back to me, or you can go yourself and do googling and research on that. What is exactly happening in the field of organic computing? Similar to it, whichever interests you can be a subject of study further. Organic computing. Today, we are storing the data. The data, you know, especially with the formulation with the technology of big data. So we have so much of data and so much of analysis, so much of algorithms going on, and the biggest challenge is where to store this data. Again, over that, the data should be made secure. So racks have been used for this one. Clouds, which was thought as a solution to this one. is again coming to a close end. So people are feeling there is a real overhead going forward. And the expectation is that by 2030, trillions of data would be there. Trillions of gigabytes of data would be there. And the current storage systems might not suffice the requirement going forward. So what is the solution? People are thinking we can create a synthesizable DNA, and one simple DNA strand can store up to millions of gigabytes of data. And this, for example, this data is stored in a very small sugar-like substance. Companies like Twist Bioscience, etc., are coming out with commercializing these things, and Microsoft has a promising challenge and has made a promising plan to store its data on the DNA in the next 3 years. So these are all, the kind of factors that are coming forward for us in the upcoming years. So this, the embedded systems market is expected to grow at a compounded annual growth rate of 4.05% between 2017 and 2023. In fact, the numbers have gone much, much, much beyond this. And those times are not very distant, where every object around us will have a small processor, sensor embedded within itself, invisible. It is interweaved into our lives. It has become a fabric of our life. Who can imagine to stay without a phone for a day? Nobody. Everything what we want is a part of the phone now. So the device, so we are connected through our phones, and we need the phone. Similarly, the technologies are interweaving, are becoming an interweaving fabric into our daily lives. Without that, we are not able to survive for some time. And everything, starting from smart clothing to smart banking, embedded systems have accentuated technology's growth by manifold. So this is why you see there is a great opportunity for embedded system engineers in the industry. The adoption of embedded systems in automotive industry, multi-core technologies in the military space, growing markets for wearables, smart apps for smart homes, and in the healthcare equipment, this is the need of the hour now. Especially with the COVID situations which we saw for the past 2 years, where it was all like untouchables. Don't touch this, don't touch this. So with those kind of things, embedded systems in the healthcare equipment has come in great demand. And the opportunities that you see are growing impact of IoT, increasing adoption of embedded systems in the smart cities. Unfortunately, as in how the complexity is increasing, the design constraints are also great. And the weakness is that more and more devices are getting connected. We are vulnerable. So we need to make sure that the security is maintained. So with this small background, let's proceed into uh, exact theme of our presentation today. So the embedded systems, okay, and let's have all the question answers collected at the end, so that we have tried to complete the maximum of this presentation. So this is nothing to do. So just for the sake of completeness, three main components. It has hardware, an application, RTOS, or a OS, or no OS system, which we call it as bare metal systems. Embedded system is an embedded, can be independent system, or can be a part of the large system, which is today. So the types of embedded systems, typically, this is what, okay, let me use a pointer. Typically, this is what we thought as an embedded system. Believe me, things have gone from here to here, and now we are here. It was just simple microcontroller with 8 to 16 bit, just with can be activated even with a battery. But gone are these days now. Yes, to some extent people are using this, but mostly either this or this. So this again is getting combined with this one. As a simple example, in our company, in the printers that we are using, we are having a processor, an SoC, which is having 4 Cortex A53, 3 Cortex A4, and 3 microcontrollers all put together in one SoC. So you can imagine the kind of computation that is being done. So the applications of embedded systems, this is a bigger role to play, starting from the medical electronics, patient monitoring systems, to electronic stethoscopes, to diagnostic equipments, to consumer electronics with your refrigerators and washing machines, all home appliances, all your DVD players and music players, and all the automation stuff, starting from your printers and MFPs, and your point of sale devices, storage devices, SD cards, all these things. And again, coming to telecom data domain, the datacom domain, with routers and switches, all these things into, I mean, making use of embedded systems, military aerospace systems, whether it be a mission critical system like satellite systems and radar navigations, weather systems or flight control systems, whether it is automotive electronics in the field of manufacturing of in the field of manufacturing of automobiles, or be it in the electrification of the powertrain, or be it in the infotainment domains, there is a huge demand for embedded systems in the automotive electronics. Beyond that, we are in the world of industry 4.0, where all things have become cyber physical systems, and there is a great demand for embedded systems in this one. And beyond all these things, we have remote automation with ventilation, ACs, home automation, which we call it as domotics now. Utility meters like your electricity meter, your water meter, everything getting just, they are just pumping the data, and the guy comes here, he just comes close to it and gets connected via Bluetooth, gets the required information and goes. And things are getting done to send this information directly to the electricity board. Yes, things have not yet commercialized. These are in the research stage. I mean, people are working behind this. Yeah, and one more thing, maybe some things of this you could have already studied during your research period or MTech period. Yes, they were during the research stage, and what we're discussing is in the industry stage. Research is 10 years beyond the industry. Ideally, typically speaking, academics should be following the research 5 years. I mean, academics should be 5 years behind research, and industry should be 5 years behind the academics, so that the academic passed outs can be easily absorbed in the industry. Unfortunately, there is a gap between academics and industry. However, research is even now 10 years advanced to what we have in the industry. So now we'll focus on these 4 domains: automobiles, telecom, medical systems, consumer electronics, and to some extent, the industrial equipment. Am I fast paced? You guys need to slow down, or this is good enough? We can proceed because we have so much to cover. We have
Sir,
rich
good
content
enough,
here.
sir.
Okay. In the automotive domain, so if you see the top 10 automotive industry trends and innovations in 2021, which you are all expecting: the great autonomous vehicles, the connectivity, the electrification, and shared mobility. Anybody has an idea of what are these 4 components called as? Because this is in great demand, and there is great work getting done here. You can see 21%, 18, 17, and 14. This is contributing to a great innovations and research field in today's world. This, apart from this, artificial intelligence and big data and human machine interface, IoT, blockchain, and 3D printing, this we call it as ACES. Autonomous driving, there are big players starting from BMW to Ford to Tesla to Intel Mobileye and Google Waymo. We have great OEMs in the field of connected vehicles: Bosch and Harman, Microsoft and Amazon, and other players. And now you can see almost, in fact, if you see the data what India has provided, by 2030, 70% of the vehicles are to be electrified. That is the data that they are providing. All that to happen, there is a great work that is going on by Again, Tesla and BMW, Toyota and Nissan, and Corporation and Volkswagen in this field. And for shared mobility, right now we already have Ola and Uber. So these guys are now making their step a leap forward for making their services with autonomous driving. We will see how the applications are going forward. So the skill sets that are required today for all these things, AI, ML, data, and embedded systems, everywhere it's almost the same, apart from some places where we have cloud stuff. So if you see this data was an old data in 2017. Now things have changed much. So 70 to 90% of all innovations in vehicle development are nowadays based on embedded systems. That means to say 30 to 40% of a modern vehicle is cost. The cost of this one is because of embedded electronics. Where are we really investing and where are we really working in the field of in the field of automobiles? These are the different places where electronics have been applied, starting from your adaptive cruise control and collision warning, night vision and lane warning, be it mobile phones or digital radio, audio systems, GPS, voice recognition. Now you see MG Hector, the advertisement itself is Internet Inside. The telematics to control all the traffic and related information of fleet, rear seat entertainment and infotainment, multimedia systems. You have a heads-up display so that the driver is able to see the maps directly on the display on the glass. And the reverse park assist, the games consoles, the instrument clusters. Earlier, if you see, maybe anybody who has purchased their vehicle that we used to have in the Maruti in our old vehicles is now completely changed. You have a simple LCD sitting there, and you can configure what you want to see. Whether you want to see the average fuel economy in that, or you want to see how the engine is getting propelled, or you want to see how the speedometer reading, or you want to see the other settings inside that. So you're able to control the clusters at this in the dashboard. Tire pressure monitoring assistance system, and the other side there is a work for the comfort and convenience of the passengers. So the embedded electronics are applied in all these different domains. The automotive industry, if you have to broadly divide where exactly the works are going on, in the chassis system designed to assist the driver in oversteering, understeering, and rollover situations with the ABS coming into picture. There is a design team that is working on the ABS. There is a design team working for the airbag systems should inflate in about half a millisecond after a crash. Is this a soft real time or a hard real time? Anybody can guess? Any
Hard
guesses
real
here?
time, right?
Yeah, that means to say it cannot cross 1 millisecond. Just imagine a person has confronted with a crash, with an accident, and the airbag systems are not able to inflate within 1 millisecond, less than a millisecond now. Then there's no point in the airbag systems that get inflated after that, right? Because he might lose his face by that time. The powertrain, this is a big area now in the field of electrification, which is nothing but the power is transmitted from the engine to the gearbox to the driving axis, which includes the engine control, fuel injection, engine speed, valve control, etc. So this is majorly on the driver assistance stuff, and this one is on the body and comfort electronics with the climate control, locks, window lifts. Here things are coming in much more into picture. Rain sensing wipers, you can imagine just a small application, right? When the rain is coming, you can imagine a autonomous car with no driver inside the car. How will he able to control the wipers? So the rain comes in, and the screen windshield should be able to sense that there is a droplet of rain in that, and the wind and the wiper should start rotating. Wiper should start wiping the windscreen. This is the kind of technology that is coming forward. So small things are making big difference. And again, as you remember, I would have told this: X by wire, steer by wire, shift by wire, throttle by wire, brake by wire. Earlier, the mechanical parts, which were just only mechanical, and now are now getting replaced with the electronics and and computer systems. Multimedia and infotainment, starting from your car stereos to internet connectivity, wireless and telematics, which gives information about the traffic, about the fleet management, especially for the people like Uber and Ola, where my car is at this point in time, and the theft systems. All of these are the things where the people are working in the automotive industry. If you see the latest trends, self-driving technology is the most awaited thing in the automotive world. So they claim that with semi-autonomous features integrated on a growing number of vehicles today, automatic braking sensors, for instance. So this is kind of getting realistic sooner. And the latest developments from the Tesla supercomputer solution. Actually, these guys have come out with the hardware which is trying to get a lot of data via the computer vision, and this data is given there, and to simulate how will my vehicle become, which are the possible cases my vehicle can be hit from different sides, from the front, from the back, from the right side, from the left side. So which are the different places where the obstacles can come in? They are trying to simulate all these things. A big number of a big project is going on under Tesla's supercomputer solution. Amazon has announced the long distance lorries for with 1,500 kilometers in one day, with 360-degree perception, and it is supposed to be optimized with 20% of fuel usage. Ford has announced hidden humans kind of thing, where they are trying to plan to roll out the autonomous vehicles for delivery, and they are trying to simulate experiments how the driverless delivery vans will interact with the road users. So the design allows the pedestrian couriers to hail the vehicle, remotely unlock the door as soon as it is parked. After entering the vehicle, the voice prompts you, and the digital screens direct the courier to the locker that your courier is present in this particular location, in this locker, and using your lock key, using the key that is provided to you, you will be able to unlock the locker and get the courier and go back home, and the van proceeds. Baidu, which was earlier a just search engine in the Chinese thing, they are having a tie-up with the car automaker BAIC group, bike group, and this they are planning to roll out Apollo Moon Robo Taxi service. That means to say, automated cars will be in the same price range as those that are currently being mass produced. So this is the work that is going on in the self-driving technology. So far, we have been using Uber and Ola, and now car is also made as a service. That means to say, the good news is that nobody will truly need a driving license in the near future to enjoy the advantages of using a vehicle. So this is expected soon after the autonomous cars are a reality. The expectation is 2025 plus or minus couple of years. Driver assist, emergency brake system, and adaptive cruise control. There is a cross traffic assist. That means to say, a pedestrian is coming by, you have set your cruise control, and you have fold your legs, and the car is driving you. All of a sudden, the pedestrian comes in, or a bicyclist comes close by you. Immediate action has to be taken, and that is provided by the features of AI being leveraged on these things. With the front view camera system, interior camera, smart camera systems, blind spot detection, radar fusion center, high beam control, all these are the works that the companies are putting more efforts using the AI based features here. So this is mainly on the safety features. Cloud hosted intelligence, a big leap has happened in the cloud computing here. It was considered as a positive advantage that you can host the data in the cloud, and in the time of emergencies where no network is available, you can use the cloud data from the outs from the home. That, for example, and the advertisement that goes with the OnStar system is that an elderly woman was driving the car, and the car rolled over in a jungle, and she was lying there with nobody reachable. And the OnStar system, with which was developed with the IBM and General Motors using the Watson supercomputer. So this one, they have used it to locate the place, and she was rescued from that. So these intelligence features are planned. IoT in the cars, so that right now, if your car breaks down, the pain point is that you need to get the mechanic to your car. He comes, he inspects, he finds that there's a fault somewhere inside the bonnet, inside the engine. He has to replace a part. He has to go back, see if the part is available in shop number one, shop number two, shop number three, and get the thing. Sometimes it's not available. So your car is parked. So we don't know where it's available. So he has to keep trying different vendors. And once he finds that, he comes back, he replaces the part and goes back home. You can imagine how much time consuming is this. With the IoT in cars, it can directly send the data to the manufacturer or the dealer, and also send vehicle can report problem and schedule repairs earlier than the problem can happen through IoT methods. Manufacturers and dealers can update the vehicle firmware easily. Fleets can be managed easily and more effectively with more safety. And cars smart sensors can also help in detecting medical emergencies in the vehicles. Gone are those days where we had one insurance plan for all the vehicles. Now, going forward, the insurance plans will be made specific to the user. Your driving habits might be good, my driving habits might be bad. So there is an eye by the AI, with the deep learning AI technology. Your driving habits are monitored. Based on that, the insurance companies are able to see how many claims he's going to make for the next year. And based on that, the quotations can go differently for different users. So this is a big field. We have so many drivers, so many players in the automotive domain. So people are able to understand, or yeah, I'm just talking. And any any comments so far? Hello.
Interesting session, sir.
Okay. Interesting to sleep, or to understand?
To understand.
Okay, not an issue. Okay, let's proceed. Let's keep proceeding. Okay, so in the field of telecom, so the top 10 telecom trends and innovations. Again, the field of IoT, connectivity technologies, there is a big thing in the field of 5G that is coming with AI and ML. These are the four main stuff that are going on in the telecom domain. Before we proceed to the next thing, I will just share you the 5G vision, 5G. So the 5G, if you see, everything gets connected. So the connected house, which is nothing but which what we call as domotics today, everything inside the house gets connected. And once you are outside, before you go out of your house, your smart parking tells you that your car is parked in this particular location. You go close to your car, the car gets unlocked automatically. Infotainment gets automatically started based on your preferences, and your car to car communication gets established. We have so much data, emergency vehicles come in, and they have their way, and the water quality in your house is detected. Everything gets connected. Let's see a simple video to understand this. So I'll be sharing the other one. Let me know if you are able to hear the sound from this one. My sound is visible, audible?
Yes, sir.
Okay. Just watch this one, end to end. So you got to see so many different use cases just from one simple video, right? Hello?
Yes, sir. You're audible.
Yeah. So many different use cases from just one video. Simple technologies that are making so much of a difference. So the 5G technology is the next big upgrade for telecommunication networks. Different technologies, be it RAN from the 5G perspective, radio access networks, or be it self-organizing networks. So different companies are putting their heads into this to make it a real reality and make it accessible to different parts of the globe. Unfortunately, beyond this, so it is easy to forget that roughly half of the world's population still doesn't have the internet access, which the UN has declared to be a human right. People living in the African countries. In fact, I heard when I was just checking this one, I got to know even in the US, in the remote areas, they are not getting the access to the complete networks what they claim today. For example, 5G might be really accessible in the major metro cities, but when you go to the suburbs and the remote areas, they are still not accessible. But still, you have some network. When you come back to these African places, they don't know the internet even today. So there is a work that is going on with the data hovering, with the balloons carrying a styrofoam box which holds a transmitter and a receiver radios together with navigation and telecommunications technology. And these are made with solar panels so that they can stay in the air for 100 days. Software algorithms determine where the balloons need to go, then direct balloons into the wind moving into the right direction. There is a great work going on in this one. Companies like Facebook initially had started this project but abandoned it, and now Elon Musk's old company, I mean, a new company which was started in 2002, but it is old now. SpaceX is also driving. They claim to be dominating the Mars now. So they claim they also are working on making. I mean, once they have this complete sky-based internet technologies with offering the solutions, hopefully the internet is expected to be a dream for the complete world. This technology is used especially in two situations. Number one, in the time of natural disasters, where the, the towers have gone hayway, for example, floods, famines, any earthquakes, so you're not able to talk to the people there. You're not able to talk to the people there. In that place, this comes handy. So the second part is in the time of in the times of in the times of events. For example, you're holding an event there, and so many different people are expected in the crowd. So you need to boost your 5G network, 4G network, 3G network. In those places, these become handy. So let's proceed. We have so much still. So in spite of all these things, there is a big demand for cybersecurity today. A company called as IoT AI creates an advanced sensor platform which combines network connectivity, cybersecurity, analytics operating in the edge networks today. And all these things are performed with the ML algorithms. Network optimizations, you see so much of data is present and is culled from devices, networks, mobile applications, geolocation. So much of data is coming there. What are these guys doing there? Now we are using the standard plans, right? For Airtel 200, 299 plan, 499 plan, 599 plan. But these are standard plans. So now with the powers of technologies that are coming today with the AI and all those things, these again will become specific to you. You might not need the internet so much. He's an elderly person. He needs to talk more. His talk time will be increased and the data will be decreased. You are a Gen Z or a millennial and you need more data. So for you, talk time doesn't matter. You can talk via internet also. For you can customize your plan based on the need. So the network guys can customize it and give a selected plan for you. So this work is going on in the field of network optimization. A big place where AI is involved is predictive maintenance for any device. So innovative solution by AT&T are using drones to expand its LTE network. And when the things go bad, they are trying to find the ways much before it really goes bad. Hence, it will help them reduce the maintenance cost. Why nowadays this has become a very common thing. Virtual assistants for any customer support. Any customer support you call, there is a chat bot which picks up, which gives you the option, and if it's able to solve, it's able to solve. Great. If it's not able to solve, then it routes it to the actual assistant. So now this has become a reality. RPA, things which the humans used to perform are now getting performed by the robots. Again, with the new technologies coming, RPA is also coming for depletion. But now, however, using in the field of cell operators, telecom domain, there is a big thing that is going on in the RPA. Companies like HSBC, banks like HSBC, and different things. In fact, one of my friends is really working into that RPA domain. He told 65 people's 1 year job is now performed by 2 people with the use of RPA and for the complete year. Is this not a saver for the company? So blockchain, one simple example I will give from the automotive domain is that a car is getting manufactured. Say the engine comes from Japan, and the shields come from US, for example, and the tires come from Korea, for example, and the assembly happens in India. So now how will you make sure that the engine that is coming from Japan is untampered? How will you make sure the tires that are coming from Korea are untampered? So chip, once the product is manufactured, a chip is written with the fingerprint, and this information is locked. And when the second component gets connected, so 1 plus 2, at the end they are going to add the security stuff. Third component gets connected, 1 plus 2 plus 3. Third, 1 plus 2 plus 3, a fingerprint or MD sum, MD5 sum, or integrity check or security algorithms are added there. So at the end, you see, when the car is in front of you, you know the car's engine has really come from Japan, the car's tires have come from Korea, the windshield has come from US, and the mirrors have come from Spain, or whatever it is. So these different things will tell you that the integrity is maintained. Same goes for all things, including the network. So in the field of healthcare, there is a big thing. Gone are those days where embedded systems were used only for these simple things, be it BP monitor or MRI scanner or CT scanner, defibrillator or ECG or EEG, sonography in wearables. This is what was there earlier. Now you see the healthcare has gone much beyond the expectation. We have intelligent diagnostics. This is an overview. I will just cover in brief these things in the next slides. Approximately 12 million Americans are misdiagnosed in outpatient clinics manually. For example, even in our case, even in India for that matter, if you go there, the moment you go to the doctor, you will not get the answer immediately. He will write n number of tests, and you have to go to the diagnostic center, get the test done. They will take their own sweet time to give the results to you, maybe in hours, maybe in days, and then the result comes back to you, and you again have to take an appointment to the doctor, go back, show the diagnostic, and then based on the results, he will do his prescription. Right? This is a normal phenomenon. However, now with this intelligent diagnostics coming into picture, physicians can now non-invasively assess the presence of a coronary artery disease, a critical stuff, in a single visit without even a radiation, exercise, or pharmaceutical stressors, using physiologic signals naturally emitted by the body. Delivers an improved diagnostic solution previously, which used to be done with invasive, expensive tests, all these things. So these technologies are coming into picture to make their lives much easier. In the interest of time, we'll be moving fast. So drug discovery, which was taking 12 years on an average, 12 years on an average was the time taken from the research stage to the commercialization stage. Now, all these are getting automated via AI. That is why you see even the COVID vaccine, for that matter, one was emergency, it had to be done. And the other thing, what tests were performed? That clinical trials and preclinical testing was performed using the AI algorithms. So a key differentiator between AI-enabled and traditional drug discovery process is that AI replaces the need for a human to make a hypothesis. However, once this hypothesis comes out, it has to be validated by a human even now. So there is a great work going on here in the field of medical devices and robotics. In fact, the companies are coming out with the robots to perform the surgeries. And in the last CES, CES, every year there's a CES show to display every company comes there in the US to showcase what is that they have done this year and what is that they want to promote. So it's electronic show. So in that, this was shown this year that the robotic surgery system, this is the only robotic surgery system which is approved. So there is a great thing that is done in the field of robotic surgeries. This is now has become a norm using your simple applications, which you are able to reduce the registered nurse time. You can imagine people who are aged, our elderly parents, if they go bad with the health conditions, it's so difficult for us to maintain. So people are having nurses at home, and believe me, you know the cost per month in India, in Bangalore, it comes close to 40,000 rupees. How many of us can afford that? This comes into play where you are able to save, you are able to give a care bot. That means to say everything is getting monitored via simple application. AI enabled home care solutions can remotely assess patient symptoms, alert the clinicians whenever it is required. So the registered nurse doesn't have to stay with the patient for long. So different. I mean, I've just shown one application. There is a great work going on in this domain as well. 3D printing. So so many different things are into picture, starting from the prosthetic teeth, prosthetic arms, customized shoes, orthotics, etc. Now they are claiming this is again this year's CES product. They claim that for the next few years, newborn babies will get tiny sensors within first few minutes of their birth. This is implanted in the infant's body within few hours of the delivery, and this is provided. This sensor will provide all the biometric data that is required for the next 2 years, which can be used, which can be monitored by the health professionals to assess, to guide in the proper way. There's a ring for adults which was made, especially during the pandemics, and had we had it here during the COVID times, it would have been so much helpful for us. So many people were just taken up, especially in the COVID wave one. So many people were just lifted and sent into different apartments or different places, quarantine centers, where people, their near and dear ones, couldn't even track them. So had this sensor been available at that point in time, it is just a finger ring, and the finger ring will tell where the person is right now. Apart from that, so robots are used in the chemical labs, bed sensors to tell how many beds are free in a given hospital. Simulators are used with AR and VR for the doctors to practice their surgeries beforehand. It is becoming so they don't even need a human patient there. They are trying to simulate this one for their practice. Digitization of hospitals. Now everything is even now a man-made process. For the cleaning, for the management of all the bed sheets and all those things, disposables, how many are coming, how many have used, all those things. Digital, they call it as hospital 4.0. There is a great innovation opportunity there. So in the field of healthcare, you can see so many different companies are working on it. Industries and factories. In the interest of time, I'll be just moving just one two slide in this one, and then moving to the next one. So industry 4.0. Earlier we had the mechanization, water power, steam power, mass production came into existence. Industry 2.0, computer and automation, and now we are in cyber physical system age. Previously we had in fact, you can imagine an industry, a factory, they couldn't even demand how many machines will be sold in the next 1 year. Capacity planning, how many machines I should plan, and where should I store them? Warehouse problem, unexpected equipment failures, downtimes, supply chain bottlenecks. You go now I heard that when you go, in fact, all the cars are in demand for the next 6 months. Why? Supply chain bottlenecks, insufficient or unsafe workplace process. All these things were a problem. Now, with things coming into picture, all these things are getting automated. In the product R&D, robotics are used, 3D printing is used, AI is used, AR is used. In the resource planning and sourcing, Blockchain is used with supply chain. In the operations and monitoring, IoT and cyber security is coming into picture, and cobots are coming into picture. In the machining, production, and assembly, robotics, we here call it as cobots in the field of manufacturing, are coming into picture with 3D printing. Quality assurance has been promised via computer vision. And warehousing, AI is used for scanning, and robotics are used for deploying these things. And autonomous trucks will take all these things and deliver to the required warehouses. So all this process is getting automated now. And here, all of them will need the embedded systems. So are we skipping this? So now coming to the last part of the presentation. So we have the consumer electronics. You can imagine AR shopping experience. Anybody who has done AR shopping experience? No. Okay. So in fact, recently there was a thing which was launched, AR and VR shopping, especially in the COVID times, where you couldn't even go to a mall properly. So you are able to shop the mall via the AR and VR applications. It's like just a shopping experience. You're going to the mall, you're picking up whatever you want, you're dropping it into the basket, and then at the end of it, the basket goes to the counter, you pay the bill, and that gets delivered to your home. Same thing in the field of clothing. You go stand there, you like a dress, you purchase that. It will show if you apply it on your body, what is the size, what is the shape, how you look at it, and once you are okay with it, just take it, and simply by not putting it back on the shelf, it is yours. Just make the payment without even having to swipe. Earlier, so big, even now, so big TVs we have 65-inch and all beyond. It can be converted into a simple roll like this, which unfolds itself into a giant TV when it is required. Electricity, we have so many Bluetooth devices. How to charge all of them? You cannot keep on connecting one after the other, right? So this electricity has come into picture, electricity through the air. So you can, within 80 feet radius, you keep all these devices. It gets charged to you via simple one charger. Now, the air things can analyze the risk of indoor virus spread. That means to say, it will analyze what is the kind of, is it safe for you? Is the temperature safe? Humidity safe? What is the carbon dioxide emissions from the people breathing? And then rank how easily the virus might move into the room. If the rating is poor, it suggests timely solutions like increasing the workflow, humidity, kicking any extra people out of the room. The biospectral OptiBP app, we have the hardwares now, right, for measuring BP. This app, this was shown in this year. So this app just uses the camera and checks your biometric, and then will be able to show the BP offhand. Still, you can just check this OptiBP app, biospectral OptiBP app, still available, but the app is not downloadable even now. Maybe some more time it's required. So it's all these things are just removing the old stuff of BP. You need to tie the cuff, pressure cuff, and you need the monitor, hardware. Nothing is required. And they claim to be working even on old 5 to 10 years old smartphones. This is an innovation. So in fact, I don't know how much of this is true in India at least. So people were leaving the kids in the hot car and just going, thinking the kid is not there. I mean, they have not brought the kid along. And later on they realize, oh, I have left my kid in my car. So this is a simple application. They're just tying the Bluetooth of your phone with this small little thing which is there with the baby. So whenever the connection is lost, it sees you are not there in the car, but the baby is there in the car. So it creates an alarm for you. 3 different types of alarm. Simple notification, then sends calls, and then sends messages to the
return
emergency contacts.
So better you take that xerox of the textbook or you read this, okay? So you don't have any other options.
Zakir sir, you muted yourself. Zakir sir,
Hello?
sir, you had
Was I
muted
muted for all
yourself.
this time?
No. Just from the previous
Just
slide.
now. Okay, great. Thanks a lot for reminding. Yeah, so we are close to the closure. So please bear with me for a couple of minutes, at least 5-10 minutes. Okay. So this one, I don't know how much. So I covered this slide. So I was on mute for this.
No, sir, it was being done.
Okay, great, done. So electric cars with solar panel, just not electric car, but also with the solar panels. You see the pucks here, right from the sides, top, all these things. So the solar panels are connected here so that this gets charged via solar also. And this was shown in the CES show this year, which is nothing but the Sion's motors, Sono Motors Sion electric car. So it can get the charge for 21.7 miles while driving, which is enough for you to drive for free with the sun energy. You can imagine an app for controlling your perfumes. A simple cylindrical gadget holds 3 vegan scents, and you can prefer. So you want to go to a party, so the scent is different. You want to go to the office, your fragrance should be different. You want to go to school, college, your fragrance is different. So your preferences are stored here via AI powered assistant. This is possible, and the app can control what kind of fragrance you need today. Security systems, water security systems. We just have normal pipes, right? Now things are coming with smart pipes. So this one, if there is a problem in the pipe, it can shut down water in the event of a leak, or purge the pipes if there is a risk of them freezing. It's all synced to and controlled by a simple companion app. You're not there at home, there is a water leakage, you get the notification, you can control sitting in the remote area of the place. You have elderly person in your home, you have a child at your home, you have left him for some time, you are afraid if there is an intruder coming inside. You can keep a watch on where is that little child, or where is that elderly person sitting. He is safe. Has anybody intruded into your home? All this can be connected via simple Wi-Fi waves filling. In fact, tech also gets into the bathroom. Alexa is now built into Numi, so you can ask it to flush. Everything controlled via an application. And the stillness bath is a Japanese style square soaking bath, which is a luxury infinity pool. You can control the temperature, turn on atmospheric lights, dispense soothing essential oils, everything at a soft command. Have you ever wished your showerhead could pump out water and tunes at the same time? There is a Bluetooth speaker attached to this one now. So these are all the different innovations that are happening in this consumer electronics field. The cuddler, funny but fact, but so it can understand the human breathing and imparts soothing sounds of heartbeats, lullabies, and guided meditation. Earlier, we had our moms doing this for the kids, but unfortunately, the moms have become very busy. So the instruments are taking place and giving a lullaby sound for the kids to make them sleep. The follower, this is an old thing. I have just kept it for the purpose. So this one, you don't have to drag this smart luggage. So it's a Bluetooth connected simple suitcase. You keep the Bluetooth dongle in your pocket. You keep on moving, this will follow you. This I had showcased in 2018 when I presented this presentation. And last year I saw this out in the market. You know how much the cost is? In India, it's 65,000. People are leveraging. So MEMS, yeah. So it can detect the home air quality, detection of harmful gases in the home or factory. It can also detect the odor. So that means to say, you can keep this inside your fridge and see what food is really cooked, what food was cooked 1 week ago and is mixed and given to you. Power to the processors, EEG, which was considered very costly, non-affordable, is now at your reach by simple wearable headband at your place in a simple application. Yeah. So last but not the least, especially in the ADAS system, automotive driver assistance applications. So AR and VR are used to track the eyeball movements where he is looking. So for example, he is looking into a laptop, then he might want to dim the light. He want to move to a different screen. Options are shown to him right there. He is looking at the fan, so he might have to switch off the fan, switch on the fan, slow the speed, increase the speed. All the options are shown to him. So that eyeball tracking is a field that is work in progress. In a nutshell, technologies are emerging to be applied on embedded systems. Innovative solutions can be provided by identify the pain points for the people in the society. It's not great we make gadgets. It's great we solve somebody's problem today. Understand the people's problem today, the society's problem today, which are the pain points. Make prototypes, and the students can make the intern community can make the prototypes. You just need to guide them. They can holistically work to solve a problem. They are technically skilled and equipped now. They can apply a given technology and to think of a specific hardware. This will open them the ears and feathers for becoming future entrepreneurs for the country, and they can help them become better engineers for corporate designing the best in the class products. So with this, I thank all of you for attending the session. Thanks a lot.
Rupa ma'am?
Yeah, somebody has raised.
Yeah, you have any query? Rupa ma'am? Okay. She's not responding. I would like to thank Zakir Ahmed sir for taking out time from his busy schedule and giving us in-depth knowledge of embedded systems, SWOT of embedded systems, factors propelling embedded systems, giving us applications, various different applications of embedded system, including autonomous vehicles, concepts of IoTs in cars, touching upon telecommunications and 5G, consumer electronics, augmented reality, virtual reality, and various emerging technologies and different applications. Thank you very much, sir. Thank you for the interesting presentation.
Yeah, thanks a lot. Hope it was useful use of time.
Yes, sir. Yes, sir. Very, very much useful and very interesting session, sir. I think you can see in the chat box, people are responding.
Yeah.
Thank you so
So
much,
thanks a
sir.
lot for your time. Yeah, thank you. Thanks a lot.
Dear participants, feedback is shared in the chat box. Kindly fill the feedback for this session. And there is a slight change in the schedule. Now we'll continue with the resource person from session 1. I hope Mahantesh sir is available. Mahantesh sir, lunch break will be from 1:30 to 2. We'll just continue with session 1. Lunch break is from 1:30 to 2.
Okay, madam. Fine, then proceed. We'll proceed.
Okay, sir. You can start with the session, sir.
Okay, madam. Fine. We'll continue. Good afternoon, all my dear faculties. Can you hear me? Can you hear me?
Yes, sir, you're audible.
No. So we are discussing with introduction, history. Then after that, we came to know about a common matrix if we consider, like cost wise if we consider, non-recurring engineering cost wise if we consider, size wise if we consider, power wise if we consider, flexibility wise if we consider, or as a time to prototype. There is nothing but build a working version of system wise if we consider. So these are all common metrics for whatever embedded product or as embedded system you are planning to make out with. And expertise with both software and hardware is needed to optimize design matrix. So that we came to know. So how they used to make out with the power, performance, size, and NRE costs. So now look towards time to market a demanding design matrix. That is nothing but what time requires to develop a product. So within that time, you need to have what you need to market, and you need to get whatever the makeout, whatever design you are planning it for. So losses due to delayed market, again they may make what they may disturb your revenue. So that's what they just shown here. So if we make out a simplified revenue model at present, what you are having it here, the peak whatever that is making it, so almost the revenue is maximum there, or as the average time to market constant is, if we consider it for 8 months like that. So delays can be what delays can be costly. So like that, we just considered one presentation here. So simplified revenue model wise, if you consider product life, if you consider that, we will just make it with that 2W and peak at W, what that is making at a peak, no? So product life, okay, the maximum the product can be sold. After that, almost the product life will decrease like that. Then triangular area, whatever you are getting it here at present in this next slide, I think that might be visible for you. So at present peak revenue, and if you make some delays there, so the delayed one, and similarly a peak revenue from a delayed entry, you will be getting it here at present what I'm showing it in this slide. So just imagine that area, how do we calculate half into base into height like that. So at present, one time if you want to make out half into 2W into W, like, then a delayed, if there is any delayed product or a delayed launch like that, if it happens, how will calculate whatever the delayed version that used to make out loss like that. If you want to calculate the percentage, you will be going it for this half into W minus D plus W into W minus D, and percentage revenue loss wise if you want to calculate it. So that can be calculated with the help of D into 3W or 3W minus D by 2W square into 100% like that. So with few examples, if you consider like D, we can take if we consider for 4 weeks. So that will be at present they just considered for the second line. If you just go with they just considered with the 3 to 26, 26 minus D, how much? D is 4. So that almost, if you put it in that percentage revenue loss, that will come up towards 22% if you make with a 4 weeks delay. Similarly, 10 weeks if you make out again for 10 weeks, percentage revenue loss if you consider, so that will be costlier. Always delays are very costly. So like this, the demanding whatever time to market, a demanding design matrix is very important. That we have shown it here. Then NRA and unit cost matrix if you want to calculate, that is nothing but cost. As we know, cost is nothing but what if you want to make out, or else if you want to if you just want to make out with one product, so that product may cost less, but NRE cost, non-recurring, whatever the estimation that used to happen behind that, whatever the machinery you are using, or is whatever the equipments that are required to make that model. So that NRE cost, whatever models we used to bring to make that model, so that is nothing but what NRE cost. So even that used to matter very. That is very important actually. The one-time monetary cost we used to make out with for designing the system. So what happens here? total cost will be what NRE cost plus unit cost like that, and the pre-product cost wise, if you consider, that will be total cost now. So we can just make out with at present, if we consider product per product cost, total cost by number of units, and that will be equals to what NRE cost by number of units plus unit cost like that. So examples, if you just make out with the NRE that it used to make out, or whatever the components required to make out NRE, that will be 2000 like that. You just mentioned with, and units per unit if it costs around $100 like that. For 10 units, if it costs the total cost will be how much? 2000 into like that. You are getting one sum. So pre-product cost if you consider, we need to divide this 2000 by 10 plus 100. 100 is nothing but unit cost. So you will be getting per product cost now. So that will be equals to what? 300 like that. We need to make out technology wise, if you are planning to make out any product, like any processor, if they used to come as controller that used to come for application based. So these things are very important. Then similarly, comparing technology by cost, that used to make out best dependence and quality like that, they just mentioned here. And the performance design matrix, if we consider, widely used measure of a system wise, if we consider like a digital camera example, if I consider, then what happens here? A user cares about how fast it processes image, like within a fraction of seconds if it is making it, or if A and B images are cameras images, that used to happen with a short span of time. So the response time will be more. No? So they used to call it as always the performance design matrix wise, whether that is having latency or that is having a throughput, also performance wise how that used to look like. So these all things, performance design matrix are very important there. And next, coming across embedded system technology. Embedded system technology wise, if we just make out with, we are mainly considered with the processor technology, what processor they are having as a processor type, then IC technology. So IC, what IC technology, or which VLSI if you consider. So like the technology that used to make out the technology behind this embedded system. Then design technology, how we used to make that design, and what are the performance or analysis which are involved with this design technology like that. We are having a technology for embedded system. First one, if you consider process technology, just look at here, this processor technology, we are having general purpose processor, application specific processor, and single purpose processor. As the name itself, we can just analyze general purpose processor. So that can be used for what the processor can be used for. A general, always it can be used for many applications. Always the revert back towards some applications can be made with the help of this general purpose processor application. Only particular specific application wise, single purpose, the processor can be used only for that, like that. So that's what the processor technology, the architecture of a computation engine used to implement a system desired functionality, and the processor does not have to be programmable here. Processor not equals to or not equals to general processor. Then processor vary in their customization. At present, we are having what nanometer technology like that. As the processor, how they used to make out for what applications they are using it for like that. There are so many conflicts involved with that. So according to that, they used to proceed with. If I just consider with general purpose processor, at present what you are seeing it here, program memory you are having, then instruction register, personal computer, they used to interact with control logic and state register, where the controller has to be it has to understand whatever the program memory or assembly language, whatever C code you are writing, whatever embedded C code you are writing. So they should come up with what you are planning it to make with this general purpose processor like that. They used to make or they used to communicate, and they will have interact with the control logic and state register in controller. Then data path with the register file. Then whatever the ALU that is stored there. Then memory. That almost they used to make out almost a programmable device used in a variety of applications. So the best example is a processor. So as I told, processor, always we'll just come to know processor, controller almost in a separate chapter. Then features wise, if you consider general purpose processor, program memory, they're having the general data path with the large register file and general arithmetic logic units like that. And user benefits wise, if you look at, So general purpose, user benefit wise what? Low time to market and NRE costs. So actually they are low to, it takes almost lesser time and NRE costs are low like that, and high flexibility at present if you consider with the user benefit. And the previous technology, if you consider Pentium, they is just the most well known, but there are there are like hundreds of others we are having it. Then single purpose processor, if you consider processor wise, as I'm telling. So here what happens, digital circuit designed to execute exactly one program, that might be a coprocessor, accumulator if you consider, also peripherals if you consider, and features wise if you consider contains only the components needed to what execute a single program, as I told, and no program memory you are having. Benefit wise, almost, of course it should be fast, low power, almost 3 volt or 5 volt, 12 volt like that. Fast, low power, small size. So like that, we need to what? We need to bother about cost wise. Then application specific processor wise, if you consider programmable processor, optimized for what? Optimized for a particular class of applications, and having what? Having common characteristics. It should have common characteristics. Then only application specific for those. Compromise, whatever they used to make a compromise between general purpose and a single purpose processor, they used to make out with the instruction register, and personal computer if you consider with the control logic and state register, they used to make out there. Along with data path and program. Then feature wise, if you consider for this program memory, optimized data path, a special function which we are having, again benefits wise, some flexibility we are having, good performance, and power size wise if you consider, almost they are good, like one parameter we get it from this application specific processor. So these are nothing but what the processor wise if you consider, that is nothing but what processor technology in embedded system. Then similarly, if we just proceed with the IC technology, what that used to happen. As we know, IC technology, again you are having few more, full custom IC, semi-custom ASIC like that, then programmable logic devices like that. You are having three main technology, or else IC technologies here. So what happens here, the IC technology, the manner in which digital or as a gate level you are having implementation is mapped into what? Into an IC. If we consider a very large scale integrated circuit, at present if we consider cadence, you may consider 180 nanometer technology, 90 nanometer technology like that, whatever they used to make out with academics. So we just, if we push it towards somewhat smaller, at present what, nanometer, still very small nanometer technology wise if we consider full customs, we need to make out gate labels in such a way what they should be what, that the size should be very compact, like that. By considering these few concepts, actually power analysis wise if you consider, cost wise if you consider, or else size wise if you consider, like there are so many concepts involved in this, and three types of IC technologies. By keeping all these in mind, we are having full custom, it's nothing but VLSI, semi-custom, ASIC as a gate array, and a standard cells like that, we used to call it as, then a programmable logic device like. Full custom, or also a VLSI if you consider, all layers are optimized for an embedded systems, particular digital implementation, like placing transistors, sizing transistors, routing wires that used to make out. If you consider for common source or a common drain, for whatever cadence you are planning to make out with. So that used to place the transistors in a proper manner, and whatever the wiring that used to make with. So they should be made in a by placing whatever the transistors you are having, the routing wires. So all these things we should keep it in full custom design. And benefits, excellent performance, small size, low power analysis. Like this, if you analyze any AC parameter, DC parameter, transient analysis like that, if you just go with the common source, common drain, differential amplifier, like there are different kinds of actually concepts, no, which are very excellent. They used to give excellent performance, small size, low power like that. So and even characterize also we can just analyze. And drawbacks, if you consider, there is NRE costs. Initial cost, it should be very high, $300, 300K like that, and long time to market. So it takes somewhat more time to market. So initially we need somewhat what investment amount and a long time to market for these kinds of full custom, or else a very large scale integrated circuits if you just trying for. Then semi-custom ASIC if you consider, So what happens here? Low layers are fully or partially built here, and the designers are left with what routing of wires and may place some blocks just to alter like, and or else that can be used to make out designs which are left out for routing. So with the help of that, again you can make out lower layers to make out with what routing, and that can be accustomed with some other design like that. They used to make with the semi-custom ASIC. Then a good performance design they used to make out, and a good size. Then less NRE cost actually, so very important than full custom implementations that used to happen with 10 to 100K like that. So then drawbacks, if you consider, still requires a week to months for to develop actually. So that is about weeks to months we need to make calls. We need to spend time for that actually. This is what involved with the semi-custom. Similarly, if you consider PLD, all layers are already there existing. So designer they can purchase an IC. They just consider that IC, individual circuit IC. Connections on the IC are either created or destroyed to what implement a desired functionality. Like FPGA, very popular as we know. Then benefits, if we consider low NRE costs, because the designs already they used to make out, no? The designs, whatever they used to make out designers. So we need to make out what are the connections. So low NRE costs and almost instant IC availability, almost every if that is instantly if that is available, again that is a major advantage, also a major benefit we can just make out with. When drawback wise, if we consider bigger, somewhat if we consider FPGA boards and all bigger, expensive, then power hungry, they used to work and consume more power, slower, or else when you want to make out also image processing like concepts and all those things, so they used to take somewhat more time. Then next one, almost related to this embedded. So Moore's law, that is the thing, but very important. The most important trend in embedded system predicted in 1965 by Intel co-founder. What happens here? Something that doubles frequently grows more quickly than what most people realize. If there are 10,000 transistors, if they used to make out with at present what you are seeing, almost 150 lakhs if you consider whatever the transistors they used to make out a leading edge chip in 2002, what that used to happen. If you consider with 1981 only 10,000 transistors, and edge leading chip in 1981 they used to make out in 2002 if you consider. So the IC transistor capacity has doubled roughly every 18 months for the past several decades if you consider. So like that, if you just make out with these types, so more laws again it is used to come. And the third one, as I told, the third one is what? The third one is the design technology. Here what happens, we need to convert our concept of design technology. So our concepts of a desired system functionality to what? Into implementation. So here what happens, you will be having a system specification. System specification, they may just make out with the complications also synthesis with their power for system synthesis, and libraries, whatever they are just making with the hardware, software, operating system, they used to consider it with, then test verifications like that. So you used to have what system specification. And here what happens, the automates exploration and insertion of implementation of a lower level. The details of lower level will be considered in this system specification that they just considered. Similarly, if you consider behavioral specification, again compilation synthesis, if you consider the behavioral synthesis, we used to consider libraries and IP if you go course, and the test verifications we used to go with the hardware, software, oscillators. Then RT specification wise if you consider, so they used to make out with what, again RT synthesis, RT components, HDL simulators, those kinds of test verifications they use it for HDL simulator. Similarly, the last one, logic simplifications, like if you consider, again you will be compilation synthesis wise if you consider, logic synthesis and library IP wise if you consider, they are just made out with the gates, cells, and simulator, again test wise if you consider, gate simulators like that. So the final implementation with the design, whatever the concepts what you are having designed, system functionality towards implementation that used to happen at the end to the final implementation. And co-design ladder, if you consider. So in the past, if you consider hardware, software design technology very different. If you consider 960, 70 compilers, assembler instructions, if you consider, they used to assemblers, linkers, they used to have machine instructions, they have 70s if you just consider, 80s, 90s if you consider RT synthesis. Like that, they just made out with the co-design ladder. So the choice of hardware versus software for a particular function is what is simply a trade-off among the various design metrics. As I told, they used to depend with what performance, power, size, the linear cost, and especially flexibility. Like that, there are so many things involved with this. Whatever the particular function-wise or trade-off-wise among the design metrics, if you consider. Then next, if we just consider basic trade-off, if you consider general versus custom, like that. So general purpose processors, you can see in this slide. So general purpose processors are what they are providing include like flexibility wise if you consider, maintainability wise if you consider, NRE cost wise if you consider. Similarly, time to prototype, time to market, cost, low volume if you just make out with general purpose processor. Towards the right side, if you consider single purpose processor, customized providing improved power efficiency, performance, size, cost, high volume. So like that. So there is the general whatever the providing improved versions for this general purpose processor and single purpose processors are there. They used to make out with PLD, programmable logic defined, semiconductor, and full custom. And we will be going it for according to again what we made previously in this type, what I should performance, power, size, NRE cost, especially flexibility wise. So like that, based on those things, we used to make out with whether we need for general purpose, whether we need for single purpose processes, like that. So then design productivity gap, as we know. So while designers productivity has grown at an impressive rate almost from past decade, not only past decade. So there are so many years they used to make out those changes that used to happen with. So 1981 leading edge chip required about 100 designers. If I just make one example. So 100 designer months, there is nothing but how much time they just need for average time, like that they are calculated here. So 10,000 transistors can be made with the help of 100 transistors per month, like that. 100 transistors they used to consider for per month, in the sense per day they used to calculate for 8 hours, like that. So similarly, 2002 leading edge chip requires how much? 30,000 designers per designer month, like many hours. There is nothing but designer months. So finally, if you consider here, whatever the value they just made out with 5,000 transistors per month, for how many transistors they are making with. So there is nothing but 150 crores, no? 150 crores by 5,000 transistors per month. So here what happens, actually there will be a gap. Designer cost increases from 1 million to 300 million, like that. So if we consider 1981 to 2002 or 2009, 2007, so IC capacity wise and productivity wise, or whatever the requirement wise, productivity wise, if we consider 0.01, 0.1, like that, we are having how much? So the increasing, whatever the gap that is making with productivity and IC capacity wise, you are having what? You are having a gap. So the situation is even worse than the productivity at present. What you are seeing here in this graph, so the situation is even worse than the productivity gap, whatever that is to indicate, because that much level, or else that level we have not still reached. So the theory adding designers to team reduces the project whatever the completion time that you used to make out with. In reality, if you consider the productivity for designer decreases due to complexities of team management and communication, like that. So finally, trends and challenges in OS and or else embedded system we can just make out with. Trends and challenges wise, if you consider, as we know, because we just consider present available what Raspberry Pi, if you consider one board, or as a mobile, if you consider, so they almost build on what? System on chip. Everything you are having it on that chip. So whatever according to your requirement you need to make out. Or else if I just consider Raspberry Pi board is having what? So everything it will be having. LAN connectivity you want, okay, keyboard connectivity you want, jack you want, so camera connectivity you want. So also some other peripherals what you are having. So system on chip. So that used to make out some trends in this trends, whatever they used to make out in this embedded system. And wireless concept wise, if you consider, multi-core processor wise, if you consider, and multi-language support. As we know, OS is supporting, OS supporting controllers or processors or application-based equipments like that. Then user interface-wise and use of open source technology. Use of open source technology again, that is in a huge that can be made with for if you are having open source technologies like that, we can just make out challenging rules, or else we can just test out. Okay, either this can reach viewers, whatever trends we are having. So there are so many advantages. Then interoperability, automation, security, power consumption, as I told previously. One by one, if you consider system on chip wise, what happens in this SoC is an what integrated circuit that integrates all components of computer, as I told, other electronic system into a single chip actually. Then SoCs are very common in mobile electronic market because of their low power consumption, a typical application whatever that is there in the area of embedded system. Similarly, if you consider wireless concept, the term wireless is wireless, that is nothing but without wire. So in the most basic and obvious sense, to what communication sent without wires or cables. So it is a broad term that encompasses all sorts of wireless technologies and devices, including cellular communications if you consider network, concepts if you consider between computers and with what wireless adapters, wireless computer access is what you are having. So there's nothing but a wireless concept is. And multi-core processor, if you consider, as we know, individual memories wise, if you consider multi-core processor, core 1, core 2, core 3, what actually they used to make out. So off-chip components, what you are having, or as a chip boundary that has to be reached properly. So they used to make out with. So they used to what cores will be having, or as individual whatever the multi-core they used to make out with, they will be having shared memory and what at present you are seeing it here. With the help of a bus interface, the off-chip components can be made out with. At present, what they used to make out with is an integrated circuit to which two or more processors have been attached for enhanced purpose, reduced power consumption, and more efficient whatever the simultaneous processing that used to make out with the help of this multiple tasks like that. And multiple languages, if we consider, embedded systems provides us what facility of multiple language. For example, ATM is what typical example of embedded system, where what happens, ATM, there are what the types of languages used like Kannada, Hindi, English, Punjabi. So they used to make up. When user interface wise, if you consider, so visual parts of computer applications or operating system, if you consider, through which user interacts with the computer or software. So what happens here determines how commands are given to computer, also that according to command wise it should operate, or it should respond. There is nothing but user interface. When open source technology, as I told, refers to program in which what a source code is available to general public or use, and or else we can modify that if you want to make what and performance wise, whether that can be giving you whatever the requirements that you are planning for your applications like that, we can just find out with this open source technology. Then next one, interoperability is the thing, but we can, whether with the help of at present, we have just shown with one concept, whether the data sharing that used to happen. So ability to work with each other, whether the interoperability that used to happen in between two models or two controllers, or so like that. If you want to know the interpolarity, again that plays a very important role, and it is what loosely coupled environment of the service-oriented architecture. And interoperability, if you consider, is when services can interact with each other without encountering problems like. And as we know, as I told, automation is automatic control. So it is use of various control systems for operating equipment, such as machinery wise, if you consider factory switching in a telephone networks, steering. So there are so many controlling concepts which are involved with automation, because everything that used to happen nowadays is based on what automation or is automatic control. Then, secure design wise, if you consider, secure design wise, at present we have shown one model actually. So that used to make out what capture system security and performance requirement and develop a secure architecture for that. Okay, whatever requirement, whatever the sensors required. So like that, we need to make first. and cheat whatever for that architecture we need what software code testing. So those things, and uncover serious problems early and avoid crash causing defects in that code. So that used to happen here in this security design. And crypto implementation leverage our expertise to what ensure crypto is what implemented securely. Then finally we come towards the power consumption. Power consumption has what again traditionally been something influenced only by what hardware developers. So they used to consider because that is consuming more power, that almost the controller's application part will be destroyed in the early stage, or else if that is consuming more power, it can affect some other bodies. So what happens? But power consumption depends not only on hardware but also on how it is used and how it is controlled by system software. So again, system software plays a very important role. So through power consumption, so it becomes what possible to test and tune for power optimization. At present, what equipments you are seeing it here. So these are the equipments. And embedded operating system, wise if you consider as an operating system, I'm telling you, is an operating system for what? Embedded computer systems. So this type of operating system is what designed to be resource efficient and reliable. Actually, whatever operating system that you are planning it for. And RTOS wise, if you consider, so resource efficiency comes at the cost of losing some functionality or granularity. If you consider that larger computer operating system provide including functions which may not be used by what used by specialized applications they used to run like. So that used to depending on a method used for multitasking. And this type of operating system is what frequently considered for our real-time operating systems if you consider. Then similarly, hardware running an embedded operating system and where what limited resources such as RAM, ROM you are having. Therefore, embedded design of these operating system may have what narrow scope tailored like that. And similarly, one more application-wise, if you consider an important difference between most embedded operating system and desktop operating system, again they are just made out with the application, including the operating system, is what usually statistically linked together into what into single executable image. Similarly, what desktop operating system, the embedded operating system does not load and execute applications. So this means what? This means that the system is only, if you consider desktop operating system, is only able to run single application. Similarly, micro controller operating system you are having, that is nothing but micro C OS like that. That is a new C OS based. They used to design by J&J Labros in the year 1991. And micros OS allows what defining several functions in C. Almost it is just preferred languages like that. And low priority task wise, if you consider, can be preempted by higher priority tasks at any time. So that's what a higher priority task use operating system. And as one example that we have shown here, we're considering operating system for Raspberry Pi if you consider. So Raspberry operating system if you consider, you will be having FreeBSD, Linux based, NetBSD, OpenBSD, Plan 9, and a RISC operating system. So these things, this is called application parts that will come to later. So they used to make out with a Windows, then 10 ARM 64-bit, then Windows 10 IoT core if you consider. So like these kinds of supporting.
Mantesh sir,
Yeah,
will it take more time?
no, ma'am, just 5 minutes, ma'am. Completing.
We are
Then
running out of
similarly-
time because 2 o'clock.
Yeah, madam, just 2 minutes. Similarly, components wise, if you consider, you will be having hardware, software components at present. What you are seeing, analog components, if you consider, sensor, actuators, controllers like that. Architecture of embedded systems at present. What analog, digital components you are seeing, converters you are seeing, software you are seeing here. So they used to make out, this one is about basic architecture. So sensors, what they used to make out initially, help you out measure the physical quantities that used to convert what? That used to convert electrical signals. Similarly, analog to digital converter. So they used to make out analog, whatever you are having, that will be digitalized. Similarly, memory, if we consider, use it to store what information, like embedded system, majorly the volatile, non-volatile memories we used to consider them. Processor and ASIC wise, if we consider, they used to make what component processing the data to measure at the output. Similarly, digital to analog converter again, then actuators. Actuators again, for an example, if I consider like robots, DC motors will be used as these things. So next, just make out with the types of embedded systems as Mr. told previously, small, medium, sophisticated. Again, what type of software is just making it small scale if you consider IDE, assembler, reader like that. Medium if you consider C, C++, Java. Then sophisticated embedded if you consider IPS, ASICs, PLA like that, complication based. Finally, coming towards advantages of embedded system, you will be having more. It is able to cover wide variety of environments, less likely to encounter errors. Then embedded system simplified hardware which reduces cost overall. So finally, if I come out towards the fast operation wise, offers improved product quality wise, so they almost play a very, very important also advantages role. Similarly, disadvantage if I just make out with to develop an embedded system needs what high development effort and it needs what long time to market. Similarly, there are so many things actually. It does not offer any technological improvement, difficult to backup of embedded files. They're very important. So with this, I just end out my this first session. There's nothing but introduction, history, and design parameters of embedded system. Then challenges on the trends in operating system. So if you are having any queries, let me know. With this, I will finish. Zahira, madam.
Okay. Done, Mahanti sir?
Yeah, madam. Completed this first one.
Okay, so we will have a lunch break now and we will rejoin at 2 o'clock for the session. I request all the participants to rejoin by 2 for the next session. So today we have a short break. From tomorrow we'll have a 1 hour lunch break. Thank you, Mantesh.
Okay, madam. Thank you. Thank you very much.